Our next little bit is going to be looking at another way that we can express quadratics. So we know what the general form is. F of x equals ax squared plus bx plus c. Now our other form is called the standard form or the vertex form, which I tend to call it the vertex form. And it's written this way, where we have the h and the k put in as translations of the basic quadratic. Now, notice h and k, remember, are the coordinates of the vertex. And I want you to also notice that it's x minus h quantity squared. So if the vertex is 2, 1, for example, just making up a number, then when we write our formula, we write our standard formula, we're going to have to change the sign on the x to put it into that formula. So the standard form would be f of x equals some a value times x minus 2 quantity squared. And then the k value keeps its sign, so plus 1. And that's how that formula works. So let's take a look at example 6. And the first thing we're going to do with this is we're going to take it out of standard form. Well, actually, we're going to find the vertex first. And then after we find the vertex, we're going to take it out of standard form and write it in general form, which means just a bunch of algebra, basically. So starting on this guide into general form of ax squared plus bx plus c, we're going to find the vertex, which if we're taking it out of the equation, we have to change the sign of the x again. So negative 5 is actually a positive 5 on the vertex. And then the k value keeps its sign. To turn it into the general form, I need to square x minus 5, which means multiply x minus 5 twice. So we get x times x is x squared, x times negative 5 is negative 5x, negative 5x times x is negative 5x, and then negative 5 is negative 5 is a positive 25 plus 1. And now we're going to take that 3 and carry it through the parentheses after I combine like terms. So I'm going to get now 3x squared minus 30x plus 75 plus 1. So the general form is going to be f of x equals 3x squared minus 30x plus 76. So you can take anything, any of these quadratics, you can take them from the vertex form to the general form, and we'll see in a minute we can go from the general to the vertex. Taking a look at B, notice that that's a plus 3. So the vertex, since inside the parentheses it's a plus 3, the vertex is going to be a negative 3 for the x value, and then the k, the y value, keeps its sign. So once again, when you're taking it out of the formula or putting it into the formula, the x changes sign and the k keeps its sign. All right, so the vertex is negative 3, negative 7. And now I'm going to do the algebra to get this into general form, the ax squared plus bx plus c form. So I'm going to first square x plus 3. So x times x is x squared, x times 3 is 3x, 3 times x is 3x, 3 times 3 is 9. I'm going to get like terms together. So x squared plus 6x plus 9 times a negative 7, or minus 7, excuse me. So negative 2x squared, negative 2 times 6 is negative 12x, negative 2 times 9 is negative 18 minus 7. So the general form is f of x equals a negative 2x squared minus 12x minus 25. And notice you can tell from that negative 2 in both the vertex and the general form it's going to open downwards. All right, so now we have some functions in standard form and we need to write them in general form. I'm sorry, they're in general form and we need to write them in vertex form in standard forms. I said that backwards, I apologize. So taking a look at this, I have negative x squared plus 4x minus 3. The first thing for me to do, I think, is to identify a, b, and c, and then use those formulas to find the vertex, hk, that was given to us in the previous video. And if you remember, h equals negative b over 2a. So it's going to be a negative 4 over 2 times a negative 1, which is negative 4 over negative 2. So h, the x value of the vertex, is positive 2. And then k is f of 2. So I'm going to plug a 2 into my function, and I'm going to get a negative 2 squared plus 4 times a positive 2 minus 3. So I'm going to get negative 4, excuse me, plus 8 minus 3, which, if we throw it on our calculator real quickly, should give us that value of 1 that I just got. So negative 2 quantity squared plus 4 times 2 minus 3 equals 1. Yeah, so the k value is 1, or that's the y value of the vertex. But we're not finished. Or maybe we are. I think we are, yeah. We do have what we need. We have the a value is negative 1. We have h, and we have k. So we should be able to write it in its standard form with the a, h, and k. So the vertex form, or the standard form, of this function is going to be f of x equals a negative 1, that's our a value, times x, change the sign, minus 2, quantity squared, plus the k, keep the sign, 1. So it's negative x minus 2, quantity squared, plus 1. All right, let's take a look at G. Okay, so starting off, we're going from this form to our standard form. A is negative 2, B is negative 8, C is 3. Let's find the vertex. H is negative b over 2a, so it's going to be the opposite of a negative 8 over 2 times a negative 2. So we're going to get a positive 8 over a negative 4. So the x value is negative 2. The k value is f of negative 2. And it's going to work out to negative 2 times negative 2 squared. We go back and put that negative on there. There we go, negative. Minus 8 minus 2 plus 3. So I have negative 2 times positive 4 plus 16 plus 3. If I put that on my calculator, negative 2 times the negative 2 squared. Well, if I can put it on my calculator, give me just a moment to fix this. Negative 2 times parentheses negative 2 quantity squared. There we go. Minus 8 times a negative 2 plus 3. And it works out to a k value of 11. So the y value of our vertex is 11. So the vertex of this thing is going to be, just a second, let me get my parentheses right. It's going to be hk equals negative 2, 11. So there's our vertex. And that means that when we write our equation of this guy, it's going to be f of x equals, okay, so the h value is a negative 2, the y value is 11, and the a value is a negative 2. It's going to be f of x equals a negative 2 times the quantity x plus 2, because we have to change the sign of the x, squared, plus 11. And we have written this in our vertex form, or our standard form.